Welcome to fourth lecture on transportation problem, solution of transportation problem by transportation simplex method. So far, in this method, we have seen that we have to do the initial allocation by any one of the three methods which we have discussed in previous class. The first one being northwest corner rule, second list cost method, or third Vogel's approximation method. Vogel's approximation method being the best, and northwest corner rule is simple but not that good method to do the initial allocation, right? Then we have seen that we have to count the number of allocations done by any of the three methods. Number of allocations should be equal to m plus n minus 1, where m is the number of rows, n is the number of columns, right? In our case, we had 4 rows and 4 columns, so the number of allocations should have been m plus n minus 1, that is 7. 4 plus 4 minus 1, that is 7, right? If we do not get that many number of allocations by this method, we may be getting 7 allocations or less. In no case by any of these three methods we will be getting number of allocations greater than 7 in this case, or greater than m plus n minus 1 in general, right? So if we fall short of number of allocations 7, then we have to do the allocations from our side, okay, and they should be according to the norms of allocated cell, that they do not form, allocated cells do not form closed circuit or closed loop among themselves by drawing horizontal and vertical line. We change the direction from the allocated cells only, right? If at all they have to change the direction, horizontal or vertical line have to change the direction, they will be changing the direction only from allocated cell, okay? So the number of the allocations which you have to do from your side, those are called as epsilon allocation. They must be placed in such a place that they do not lead to formation of closed loop amongst the already existing allocated cells or allocations, right? So having seen that, we have seen in previous lecture how to test whether the allocations done by us by using any of these three methods and filling up the gap um, between the number of allocations which you have got and the number of allocations which should be there by epsilon, then you will be finding whether the allocation done is optimal or not. Okay, for that we have seen a very small problem. Through that we try to understand the concept of test for optimality. What we do in test for optimality, we try to do one unit allocation in empty cell. In this case, where there are 2 rows and 2 columns, there will be what you say, 3 allocations, 2 plus 2 plus minus 1, there will be 3 allocations. In all there are 4 cells, so there will be only one empty cell. So if we do one unit allocation in that empty cell and we get the cost saving, okay, then that is the potential cell for doing the allocation. That means the allocations which we have done earlier was not optimal. By doing the allocation in the empty cell, if it is demonstrating the saving in the transportation cost, then we will be doing the allocation there. So we did the allocation, and we again found, just for demonstration, we again have found out the saving potential of this sale, how much cost, what is the saving in transportation cost if I do one unit allocation in empty cell, right? So I found that there is no saving, means there is increase in the transportation cost by 1 rupee, right? So allocating here will not reduce the cost, whereas allocating here had reduced the transportation cost. That's what we have to do in our big problem, original problem. So we had also seen the concept of stepping stone method in the last part of previous lecture, right? So what we did there, total number of cells in this matrix are 4 into 4, 16 cells are there, and 16 cells are there. How many cells should have allocation? Number of cells which should have allocation is equal to m, that is 4 n, that is 4 plus 4 minus 1, 7 allocation should be there, meaning that out of 16, 9 cells will be empty, right? So, yes, we have seen how to allocate epsilon. Epsilons are to be allocated in the cell which do not form the closed circuit with the existing allocated cells. Okay. If you still have the doubt, you can refer the previous lecture for allocating epsilon. There it has been detailed, it has been discussed in detail. All right. So applying that concept of test of optimality, what we do for every empty cell, for example, here what are the empty cells which we are having? A D2, a D3, then a D4, then we have B D2, B D3, and B D4, B D2, B D3, B D4, then C D1, and then C D4. Then you have dummy. I'll be right now be calling it as D only. D for dummy, and D3 is only empty. So how many? 9. 1, 2, 3, 4, 5, 6, 7, 8, 9 empty cells are there. So we have to find out saving potential of each of the empty cell by doing 1 unit allocation in that cell. If we do 1 unit allocation here, we have to adjust that allocation with other allocations. So for that, we have to find out quantity adjustment loop. So first, for example, for cell AD2, quantity adjustment loop will be formed. First will be here, then we'll go here, then here, then I'll be coming here, and then once again here. Okay, so that is one. And then if I want to find out the saving potential, what I have to do? Plus 4 minus 0. So actually by drawing the quantity adjustment loop, okay, which I may draw just for your reference. So here it is the quantity adjustment loop for cell AD2, and be sure that only one loop will be formed, and it will be formed if you have m plus n minus 1 number of allocations. So every additional allocation definitely will be completing a circuit with other allocations, right? And it will be unique circuit, right? So here there will be plus sign, minus sign, plus sign, minus sign, and plus sign. So saving potential is found by that plus 4 minus 3 plus 0 minus 0. So that comes equal to 1. Likewise, with reference to this cell AD3, we have seen in previous lecture that this loop gets formed. That is AD3 to CD3 to CD2 to D2 to DD1 to AD1 to AD3, that we have seen last time, and saving potential comes out to be 13 minus 19. I alternately go on changing the signs. Plus 12 minus 0 plus 0 plus 0, then here I come minus 3, and lastly it is coming to 13. So how much it comes? It comes 3. Likewise, you have to find out saving potential for all the empty cell, and this is a cumbersome exercise in itself. And after completing all these loops and finding saving potential, okay, positive value means that it will increase the cost if you allocate in that empty cell. For example, if you allocate 1 unit in a D2, it will increase the cost. Okay, even if you allocate 1 unit in AD3, that is also going to increase the cost by 3 rupees per unit allocated in that empty cell. Likewise, you will be getting the saving potential of for all the cell wherever you find it maximum negative. You will have to find it maximum negative. Okay, so that loop you will be focusing on and adjusting the quantity. Okay, once again your allocations will get modified, and you will repeat the same process, and this you will keep on repeating until you get all saving potentials to positive values. So you can imagine the labor involved in this process. This method is called as stepping stone method. Okay. Stepping stone method, it is called as stepping stone method because this matrix is considered to be a pond. Okay. Pond of water, and wherever you have allocation, those are considered as stones. Allocations are considered as stone, and rest of the cells where there is no allocations are considered as water cells, and where there is allocation, those are considered as stone cells. Now what you have to do, you have to jump from one stone to another. Essentially, you have to jump from one stone to another. You should not jump from one stone cell to water cell. Okay, while taking the jumps, you can jump from stone to stone, right? But in horizontal direction or in vertical direction, you cannot jump in diagonal direction. That's why the name is stepping stone method. This method is not in use because of labor involved. In this method, you will have to first of all find 9 loops, and once you find the loops, you will be doing this calculations, and then you will be finding the saving potential, and then you will be finding maximum negative value amongst these values. Then out of 9 loop, only that loop is of significance to you. Okay, and you will adjust the quantity in that loop, repeat the process. So this has to be repeated so often. Okay, so we will not, on this background, if at all you are interested in completing this problem, you can always, okay, but I will not be completing this problem by stepping stone method, which is very laborious one. So there is another method called as modified distribution method, and that modified distribution method is based on um, develop this transportation problem. Develop the formulation of the transportation problem. I will not be discussing the dual and how exactly this modified distribution method, second method of doing the optimal allocation or testing for optimality, right? Is having connection with the DL. I'll be simply explaining you what is that method. Okay, and in my later lectures, after you are well versed with this modified distribution method, then probably you may get curious about why this is happening so the reasons for that you will be finding in some of my later lectures, right? So, to make you understand the concept of modified distribution method, optimality test by modified distribution method, uh, we will be once again coming back to that 2 by 2 problem, right? So, here I have the cost 1123, and here the quantities were mm, our allocations I'll be directly taking. Our allocations were 200, 100, 100. So the intention or the beauty of modified distribution method is that for getting the saving potential of the empty cell, I have to form a loop, and then by taking the cost into consideration along with the sign as attached to the corner points of the loop, I do certain computations and I get uh, the saving potential. Okay, saving potential means the transportation saving in the transportation cost if I allocate 1 unit to that empty cell. Suppose I want to find out any means by which I will be getting saving potential for all the empty cells in one go, right? I should not be required to form the quantity adjustment loop or quantity adjustment loop or like I did 9 times in this case. If for every empty cell, if it is possible for me to get the saving potential directly, then it will serve a lot for me. It will save enormous time. Okay, so that's what we are seeing now. So that is possible, and the reasons for what I do lie in developed transportation formulation, right? So what I need to do in modified distribution method called as MODI method, modified distribution method, that is MODI method, MODI. MO stands for modified and DI stands for distribution. Okay. So what we do in this method, just understand the process, and that is very simple process. What you do, you give what is called a certain row number here, a column number here. Okay. And you focus on allocated cells only to complete to get the row numbers and column numbers. First column number you have taken 0, right? Now you find all the allocated cells in this column, and then what you do, you put certain number here so that sum of this and this number is the cost here, cost in this cell, all right? Sum of this and this number is the cost, right? Or to say it other way, inner cost minus outer number should give you outer number. Inner minus outer is equal to outer. Okay. So 1 minus 0 will be getting you the row number for this cell. Okay, once again I repeat, right? So what you need to do is allocate 0 to first column number. Okay, first column. Then you find out allocated cells in that column, and with reference to the allocated cell, what you do, find the cost, transportation cost, which is written in the corner, right top corner. So 1 minus 0. That cost minus 0 will get you the row number for the corresponding row. Okay, the same way you can find it here. 0, 2 minus 0 will get you to here. Now these two numbers will help you getting the column numbers, and those column numbers will help you getting the row numbers. This way, here the story is completing just after I get one column number, and that I can get from this row number 3 minus 2, because I am doing this calculation because this cell has allocation. I am not finding this column number from this cell because this is empty. So 3 minus 2 will get you 1. Now all these numbers we have got from allocated cells, and we now will be using these numbers for empty cell. Okay, so here we go. Here in this column, in this corner, that is left bottom corner, I am making a small square, and in that square I am writing sum of the row number and column number corresponding to that cell. Okay, so here I go 1 plus 1 2. Okay, and then at the top of this cell I write the difference between 1 minus 2, that is minus 1, and that is nothing but this value, which I obtain by doing little more work. Okay, and I am obtaining it very easily. The ease of this method or the convenience of this method is not visible in 2 by 2 matrix, but when we will be doing it for a big matrix, that is 4 by 4, you will definitely appreciate the ease of this convenience of this method. Okay, so this figure tells you that the saving potential of this empty cell is 1 rupee. Minus 1 indicate 1 rupee, so you must do the allocation there. Okay, so doing the allocation there will want you to draw a loop. Okay, right? So how you will, and only one loop you have to draw here. You were required to draw 9. Okay, no, I will be coming to that. I am comparing this problem with this. Okay, so you now have to draw the loop. Okay, so with reference to this cell, you start drawing either horizontal or vertical line till you get across the another allocation. Then from that you have to change the direction. Then from here you have to change the direction, and from here like this one. Okay, and you assign plus sign here, and alternatively to every corner assign mine. The sign should be assigned to corners of the circuit or loop. Okay, this is called as quantity adjustment loop. Minus, plus, minus. Then what you have to do? You have to find out the quantity which you can allocate here. Okay, and the quantity which you can allocate here is minimum amongst minus marked cell. Okay, I explained the reason for this in the last lecture. So here is 200, here is 100, so you can allocate 100 there. Okay, so here I go. All right, so 100 I'll be allocating here. Here I have 1, and this cost will always will have to be copied always. 3, right? So now 100 I have to shift to this cell, empty cell. Then 100 I will be subtracting from this 200. So here I have 100, 200 minus 100, and 100 I have to add, because wherever there is plus sign you have to add, and wherever there is minus sign you have to subtract the quantity which you allocate in the empty cell. All right, then 100 plus 100, 200. Okay, so this is the empty cell. We our uh, whether the allocation done by us is optimal or not is decided by the saving potential due to empty cell. Okay, right? So I will be finding saving potential of all the empty cell once again by the same method. So what I do, I allocate, I assign to first column number 0. Okay, then from the allocated cell I will be finding row number. So 1 minus 0 1, 2 minus 0 2. Only from allocated cells I am finding it, and then from this number I will be getting this column number 1 minus 1 0. Okay, then what I'll be doing in this corner, I'll be writing the sum of this and this. Okay, so column number and row number. 0 plus 2, 2 here. Then 3 minus 2 gets you 1. That what does that mean? Saving potential of this cell is 1. 1 means it will increase the transportation cost by 1 rupee. If this is negative, then it really saves. Okay, right? If it is positive, then it adds to cost. Cost will increase by 1 rupee. Transportation cost will increase by 1 rupee if you allocate 1 unit here. Okay, and obviously by every additional unit transported via this route, the cost will increase. All right. So that is to say, there was only one empty cell, and that empty cell doesn't have saving potential, right? That means the allocation which we have got here is optimal. This is what you have to do in modified distribution method. So you can appreciate the convenience of modified distribution method against stepping stone method. Lot of work is saved. 9 loops you don't have to draw, because drawing every loop requires enough amount of manual effort. Computer also has to exert for finding this loop. Okay, so this method is not used. This is obsolete method when modified distribution method was proposed. Now we will be implementing modified distribution method on our problem. So once again, bringing the story back from the initial allocation done by northwest corner rule. Okay, I am assuming that I have done initial allocation by northwest corner rule. When you will be solving the problem, you will be doing initial allocation by Vogel's approximation method. Why? Because after you do the initial allocation by Vogel's approximation method, the subsequent steps required to reach to optimum transportation schedule will be lesser. Okay, I will have to go through many steps to reach to optimal, and while going to those many steps, I may come across various variations in the method. Okay, for that I am referring to initial allocation done by northwest corner rule. Okay, so initial allocation done by northwest corner rule allocated 60 here, then 10 here. Okay, then 60 here. All right, then 40 here. All right, then 20 here. There were only 5 allocations done. 1, 2, 3, 4, 5 allocations done by northwest corner rule. I want 7. So I have to do the epsilon allocation at such a place where I am sure that it doesn't form closed loop with other existing allocations. Right? So because no allocation form closed circuit amongst themselves, so I have to do the allocation honoring that basic of allocation. So I did one epsilon allocation here and another epsilon allocation here by making sure that allocating here doesn't complete the closed circuit, right? I should not allocate epsilon. For example, after I allocate epsilon here, I cannot allocate epsilon here and here because it will be forming the closed circuit. Okay, it will be forming the closed circuit like this. All right. So now I will be applying modified distribution method to point saving potential of all the empty cell. So here modi method hmm, for optimality test, for test of optimality, whether the allocation done by us is optimal or not. So what I'll be doing, as I did in that small problem, I have put zero column number here. Okay, it's again not mandatory to have zero column number here. You may start with zero row number and find another numbers. Okay, some value, some column number or some row number you have to take zero, and this is a good starting point. And moreover, there should be uniformity in the class which refers to this video, so that if there is any lapse in the process, the answers can be found with this video, right? So 0, and here and here there are allocations. So you can get row number for this, row number for this, and row number for this. How? 3 minus 0, 3. I'll be calling this as column number, or those are commonly called as UI and VG. Okay, just for numbers. Row numbers UI and column numbers VG. 0 is the first VG I have given, and 3 minus 0 I'll be getting 3. Likewise 3 minus 0 again I'll be getting 3. I should not do 9 minus 0 because here there is no allocation. This what I am doing is applicable only for allocated cells. So 0 minus 0, 0. These numbers may come negative, positive. These numbers are unrestricted numbers. All right. Now, with these three new numbers which we have got, uh, let us try to find some new column numbers. From this, I cannot get any new column number. From this also, I cannot get any new column number. Let's try from this. Okay, I will be getting here the column 0 minus 0, 0. Okay, and here 0 minus 0, 0. Inside number minus outside number will be giving you outside number. Now these two numbers I have got. Now with from this we'll try to find this row number, because by using the allocated cell here, 12 minus 0 is 12, right? And from this you will be getting the number here. Okay, 19 minus 12 you will be getting 7. So you got, there will be unique set of row number and column number if you start with this, if you start with v0 equal to 0. Okay, if you don't have number of allocations equal to 7, then this process cannot be completed. Okay, so vice versa, converse of this, that if this is not getting completed, if you are not getting row number, all row numbers and column numbers, that implies that you are short of allocation. You need to do some epsilon allocation, or you have forgotten some allocation. Okay, at one place you will be getting only one allocation. If you get sorry, at one place you will be having only one row number or column number. If you get two row numbers or two column numbers at certain place, it implies, it tells to you that you have done the allocation which forms closed circuit with another. right? So mistakes are brought to your notice once you get into next process of getting row numbers and column numbers. Okay, if you are not able to complete this row number column number, that means you are short of allocations. And if you get more than one number at one place, it implies that your allocations are forming closed circuit amongst themselves. Okay, so now with these numbers which you have formed, which you have got by using allocated cell, you have to use them for filling up the left bottom corner of the empty cell. Okay, let me do it like this. And there in that left bottom corner, you will be writing the sum. What that implies, what that means, that I'll be telling you soon. 0 plus 12 comes 12 here. Get you 12 here. Here also the empty cell. Okay, all right. Now 0 plus 3, 3 here, 0 plus 3, 3 here, then 7 plus 3, 10, then 7 plus 3, 10 again, okay, then 7 plus 0, 7, then 0 plus 3, 3, 0 plus 3, 3 again, then 0 plus 12, 12. All right. So what these numbers are? I know this right bottom corner numbers are the cost per unit of transportation. What the numbers in left bottom corner are? Okay, we'll be seeing the anatomy of this cell, one cell. Okay, empty cell. Okay, I'll be enlarging that cell, and here this is the actual cost of transportation. Actual cost of transportation, right? And this is implied cost of transportation. Where from this implied cost is coming, the roots of this lie in uh, dual of transportation problem. Okay, so this is called an implied cost of transportation. Let's say this is L, this is M, then L minus M is the uh, saving potential. But that saving potential means it should be negative. Okay, saving potential means it should be. Instead of calling this as this value as saving potential L minus M, the better term will be cost change. Okay, if this cost change is negative, that will imply that there is saving. Okay, and if this is positive, it will mean that the cost will increase if the allocation is done to this sale. And there is one more thing in the sale which I will be showing by dotted lines. Okay, why dotted? Because this we are doing in empty cell. This implied cost of transportation and L minus M, we are doing in empty cell. Okay, and this is a allocation. Okay, in this cell, allocation will not be there. There will be another cell where the allocation will be. So let me label this as allocation. So that is the anatomy of the cell in transportation matrix, right? So now, having found out the implied cost of transportation. Now, what is the meaning of implied cost of transportation? Right? Implied cost of transportation mean the cost within which you can afford to do the transportation via that route. Here I write cost within which one can afford to do the transportation. Via that route. Do the transportation means doing transportation of one unit only. Okay. So implied cost. So to help you understand this better, let us see this in this sale. The actual cost of transportation from A to D2, all right, is 4, right? A to D2 is 4. And implied cost of transportation is 3, means you can afford to do the transportation at cost lesser than equal to 3 rupees. Okay, just to understand it better, suppose say you are going to hire a taxi for going from a certain destination, like say from Ramdev Baba to railway station. Okay, so you have the idea that this will be costing you um, the you have your own idea of as to how much cost it will take for reaching from railway station to Ramdev Baba college to railway station. Okay, and say you have the idea that it will take 3 rupees. That is implied cost. That is what you assume. That is what you assume, that within this much amount I can afford to hire a taxi from Ramdev Baba to railway station. And when the taxi comes and taxi driver tells to you that it will take he will take 4 rupees to take you from Ramdev Baba to railway station, then you won't board into that, because you have formed your own concept that it should take me 3 rupees, but he is telling you 4 rupees. Okay, so 4 minus 1, that value I write here, this is coming positive. Now let us see another case wherein the taxi driver tells you cost lesser than what you assume. For example, you have assumed in this case for going from C to D1, it has been assumed that one can afford to do the transportation of one unit at rupees 12. Okay, but the actual cost of transportation is 9. It is something like you have assumed that it will take 12 rupees for traveling from Ramdev Baba to railway station. You have assumed, but taxi driver comes and he tells you that he will take 9 rupees only. So what you will do, you will jump into the taxi, because the cost taxi driver has told is lesser than what you have assumed. Okay, so in that case, there is a saving potential. 9 minus 12, that is minus 3 costs. The difference between the actual cost of transportation and the implied cost is negative. Okay, so do it for all the cells. 2 minus 3 is minus 1, then 12 minus 10 is 2, then 8 minus 3 is 5, 3 minus 3 is 0, 8 minus 10 is 8 minus 10 is 2, 8 minus 10 is minus 2. Then 13 minus 12 is 1, 0 minus 7 is minus 7. So what we are finding here is there are the sales where the cost will reduce if you use that route for transportation. For example, B to D2, there will be saving of 1 rupee per unit transported. C to D1, there will be saving of 3 rupees transported, and here dummy to D3, there will be saving of 7 rupees per unit transported, and B to D3, there will be saving of minus 2 rupees per unit transported. So wherever you find that there is maximum saving, you should use that route. Okay, this is what we have done, and the reason for doing this is for finding the potential sale for doing the transportation, and this is the potential sale for doing the transportation. All right, all right. Hmm. So we will be finding now the quantity adjustment loop with respect to this sale, and here I do that. So for doing that, from this sale you will have to go to certain sale where there is allocation. So in this column, this is the only sale, so I must have to go to this. Okay, from this I have to go to this because this is the only sale, and then from this I have to go to this, and from this I have to go to this. This is the quantity adjustment loop. Okay, quantity adjustment loop. This is simple here, but sometimes it could be complex, like this one. It may go like this, then 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 like this, and then this. Suppose you started from here, and then it will go here, and then here, and then here, and then it may come back to this one. It may be complex like this. Okay, loop means coming back to the same point from where you have started after traveling horizontal and vertical in this two-dimensional problem case. All right. So here it was simple, but it can be complex to any extent. I mean, there can be many paths. All right. So now here you will be putting plus sign, then alternatively at all corners minus, plus, and minus. All right. So within this circuit, you have to do the quantity adjustment, and rest of the allocations will continue as those were in the previous iteration. From this, you will be modifying the distribution of allocation, right? So first of all, you take care of the modification here in this loop. So what you will be allocating here, it will be minimum amongst the allocation in this loop which are marked with minus sign. So here it is 40 marked with minus sign, and epsilon marked with minus sign. Now epsilon is minimum, that means you have to allocate epsilon here. So that's what I am doing. Epsilon is allocated there, then epsilon is added here. Epsilon will have to be subtracted from here. 40 minus epsilon is 40 itself. All right. Then 60 plus epsilon is 60 again. Then epsilon minus epsilon is 0. All right. So now what you have to do is write other allocations as those were 60, then 10, and then this is epsilon unaffected. It was not the part of the quantity adjustment loop, so that has to be retained in its place. Then this lastly 20. But in that process, you must once again count the number of allocation so as to make you know whether some allocation has been skipped from earlier iteration. So 1, 2, 3, 4, 5, 6, 7 allocations are there. So we can proceed ahead, and now it is the repetition of the same process. So I'll be taking column numbers and row numbers like here, right? First column number 0, then with the allocations in this column, you will be finding row numbers 3 minus 0, 3, 3 minus 0, 3, add 0 minus 0, 0. Alright. Then with this 3, let us find new row column numbers. With this 3 row numbers, let us find new column numbers. So this and this numbers don't help me getting new number. So this will help. So 0 minus 0, 0. This minus this, 0. This minus this, 0. Okay. All these numbers are to be found out only from costs. Alright. Now from here, you will be finding this number like 19 minus 0, 19. This exercise is valid for allocated cells only. These numbers are to be found from allocated cells. Now from here you will be going to allocated cells 12 minus 19 inner number minus outer number gets you the outer number 12 minus 19 minus 7. Alright. Now from these numbers you once again find out the numbers for the empty cell, right? So for all empty cells, let's first make the space to write the number which we will be getting. All right. So here are those cells. In fact, this number you can find for the allocated cell, but there is no point in doing that because that number will come exactly equal to this because this number is sum of this number. Already this number is sum of this two. So there is no point in writing that number once again here. So that's what we are not doing it for allocated cell because this number and this number for allocated cell is coming is same. In fact, the process used for finding these numbers is that this plus this is equal to this. We are doing it for empty cell. 19 plus 0, 19. All right. Mm, my 19 plus 0, 19. Mm, okay. Then for this minus 7 plus 3 is coming out to be minus 4. Am I right? Sorry. This plus this is coming out to be minus 4. Then 3 minus 3 plus minus 7 is coming out to be again minus 4. Then minus 7 here. Then 3. 3 again. And here it is coming out to be 3 again 3 and 19 plus 0 19. Now you find out cost change 9 minus 19 is minus 10, 4 minus minus 4 is 8, 2 minus minus 4 is 6. 0 minus minus 7, 7. 12 minus 3 is 9. 8 minus 3, 5. Then 8 minus 3, 5. 3 minus 3, 0. 13 minus 19 is minus 6. So you should be interested in the cells which have got negative cost change, means cost saving. You got it? So, one more to explain you that concept of actual transportation cost and implied transportation cost. I'll take once again the example of the taxi driver. Mm, you have come to Ramdev bus stop and waiting for taxi, and you are thinking in your mind that taxi driver should give me 4 rupees if I board in his taxi for going from Ramdev Baba to the railway station. This minus 4 implies that you are thinking in your mind and taxi driver comes and tells you 4 rupees. So that is going against your concept. This is the actual cost of transportation and this is what you are implying. okay, as per your calculations, and that is once again to emphasize the concept of actual cost of transportation and implied cost of transportation. All right. So that was just a fun. Now you will be finding out the maximum negative cost change. So here it is minus 10. So with reference to this sale, you will be forming the quantity adjustment loop as we did in previous case. With reference to this maximum saving potential sale, we have formed the quantity adjustment loop, and here is the maximum saving potential. So we'll be forming the quantity adjustment loop. Now this time it is going to be just because see, you have to take a look at it. Computer will be having different algorithm or little bit complex algorithm for finding the quantity adjustment loop. However, you can do it visually. From here, you will be going here, then to here, and then to here, and then to here. Obviously, you will take a chance of going here, and then you will point up and down because you do not find any allocation where you can go. You prefer to go over this allocation to this one. So the point is, it's not necessary to change the direction from horizontal to vertical or vice versa. Soon you see the allocation. You may cross over it, okay? Then you will be coming down because this is the only allocation, and then you will be coming to this because you believe that by going to this direction you can complete the loop. So here you have completed. Now, what you will be doing? Here you will be having plus, and then here you are having minus, then plus only at corner, and then minus. Alternatively, you have written. I'm sorry. I should have written plus here, plus at this place, because I have to do the allocation there. Then minus here, then plus here, and minus here. Okay, right? So now I have to modify the allocations. Okay, I have to first decide how much quantity I'll be allocating here. So for deciding that, I have to find out the minus mark sale in the quantity adjustment loop, and here those are 40 and epsilon, right? 40 and epsilon, right? So epsilon being lesser, you have to allocate epsilon here. So now we'll be going to the third iteration. Okay, we'll be going to. So we'll be going to next iteration. Now, first of all, you take care of the quantities which are to be affected because of the quantity adjustment loop, and rest of the quantities you will be retaining as those were in the previous iteration. Okay. See, I have to write A, B, C, D, and D1, D2 in every iteration, but it is assumed that you know that here there is A, B, C and dummy and D1, D2, D3, D4. Okay, if required, I'll be writing those things that time. So first of all, I know that I have to allocate epsilon here, right? So epsilon after I add here, I have to subtract it from this corner. 40 minus epsilon will be 40. This iteration and the previous iteration that way is vested in correcting the position of epsilon. Allocations have not been changed. Had we allocated epsilon right in our first attempt at those positions, we might not have been required to do this iteration, to carry out this iteration. That would have been saved. Epsilon plus epsilon is epsilon. It's not 2 epsilon, it is epsilon only. Okay, epsilon minus epsilon is 0, however. Epsilon plus epsilon is not 2 epsilon, and rest of the allocations you just write those at their places in their quantities. 60 here, then 10 here, then 60, though here this 60 is unaffected, okay, and then you have 20 here, right? 1 2 3 4 5 6 7 allocations we have. All right. Now, once again, we will be testing whether this is optimal or not. Okay, so for that, we will be finding UI and VJ, zero number here, and then we will be finding row numbers. Now, by now, you have understood what is that we are doing. So, 3 minus 0, 3, 3 minus 0, 3, again 9 minus 0, 9. Then here you won't be doing anything because there is no allocation. Now with these three numbers, let's find, we can find out any more numbers. With this 9, we can find out 12 minus 9, 3, 19 minus 9, 10. That is to say inner number minus outer number is equal to outer number. Now from this number, we will be getting this number, because 0 minus 10, I'll get 10 here. And from this I'll be getting this number, 0 minus minus 10, 10 here, or this plus this should get you this number, right? Now that you have got all row numbers and column numbers, write them in empty cell, right here. In all the empty cells you write them, only empty cells you do it, right? 0 minus 10, you get minus 10 here. And then this is 3 3 6, then 2 3 3 3 6 again, then minus 10 plus 3 minus 7, then 12 3 plus 10 13, then 3 plus 10 13 again, then again here 13, again 13 here, then 9 plus 10 is 19. So you have all the implied cost, you have actual transportation cost now ready for taking the difference. Okay, 0 minus minus 10 is 10. 4 minus 6 minus 2, then minus 4 here, 2 minus 6 minus 4, 0 minus 7, 7, 12 minus 13 minus 1, 8 minus 13 minus 5, then 8 minus 13 minus 5 again, 3 minus 13 is minus 10, okay, and 13 minus 19 is coming out to be minus 6. So minus 10 so far is maximum negative. So that is the potential cell where I should think of doing the allocation. All right. Now, with reference to this, you form the quantity adjustment loop. So you must have to go from here to here, because that is the only cell, and you have to change the direction from allocated cell only. And this is the only cell, so you come here. Okay, then this is the only cell, so you will be coming here. When you go vertical, this is the only allocation, not cell. Okay, so from here you can either go here or here, but going here doesn't make a point because your journey will stop there itself. So you will be coming here, then from here you will be coming here so as to reach to the destination from where you started your journey. So you will be marking plus, then minus, then plus, then minus at all the corner points only. Okay, minus, then plus, and then minus alternatively. Okay. Um, Alternately plus minus plus minus. Now amongst all minus mark cell, this and this, 10 is the minimum quantity. This is 10, this is 40, and this is 20. I am looking at minus mark cells only. So 10 is minimum. So at this place, I have to allocate 10, whereby many allocations will change. So let's come on to the next iteration. All right. Okay. So this is the next one. First of all, I will be writing the allocations which are going to change. So this is first going to be 20. Okay, this is going to be 20. Then 20 will be subtracted from this 20, getting you 0 there. I'm sorry, not 20. I decided to subtract 10. 10 is to be allocated here because 10 was minimum, right? That is 10. So 20 minus 10 is 10. The process is such that there will be no negative allocation in any of the cell. You do the allocation here such that any of the cell doesn't get negative allocation. So epsilon plus 10 will get you 10 here. Then 40 minus 10 will be 30. This is all quantity adjustment because you see that in this column the requirement was 20 and that is 20. Again in this column it was how much? 40. If you refer back to your original solution. Okay, we'll come back to that anyway. So 30, then the 60 will be written, but that will be writing later, and here there will be 10. Okay, epsilon plus 10, 10 minus 10 will go up. Okay, so how many allocations got modified? 1, 2, 3, 4, 5 allocations and 6 allocation, which happen to be the corner of the quantity adjustment loop. 1, 2, 3, 4, 5, 6 corners were there. So 6 allocations got modified, and the remaining allocations you have to write those as those were. So here is 60 and this also was 60. Total allocations 1, 2, 3, 4, 5, 6, 7. Once again, you do that game of row numbers and column numbers. Okay. So here you write 0. Then you get row numbers and column numbers from the allocated cell. So 3 minus 0 gets you 3. And 9 minus 0 gets you 9. Now from this you try to get few more. 12 minus 9 will get you 3. Then 19 minus 9 will get you 10. And this new numbers will be helping you to get few more numbers. So 0 minus 10, because here there is allocation, I can do that minus 10 here. And from this minus 10, 0 minus 10 will 0 minus 10 will get me 10 here. All right. Now, from this 10, I'll be getting this last number. This process is to be completed in one shot. If you leave this process in between, you have to start doing this process right from beginning. Okay. So 3 minus 10 will get you minus 7. Okay, so all row numbers, column numbers have been completed. Now you find out the implied cost for all the cells, all the empty cells. So here I go, and here. Okay, so 0 minus 7, here I get minus 7, then minus 10. Okay, the sum of these two things you have to write here. 3 minus 10 minus 7, then 3 plus minus 7 minus 4, and 3 plus 3 6, then 10 plus 3 13, then 10 minus 7 3, right? Then 10 plus 3 13, then 10 plus 9 19. Am I right? 10 plus 9, 19. All right. 19. Now you find the saving cost change. The 3 minus 7 is going to be positive. You may or may not spend your time in doing the calculations. This is coming out to be positive. Okay, wherever is positive, you simply write positive value is not of any use to you. Value, as long as it is positive, it is not useful to you. Negative values are useful. 4 minus 6 is minus 2, so you must write it here. 2 minus 4 minus 4, it is coming positive value. 0 minus 7 positive value. 12 minus 13 minus 1. 8 minus 3 positive value. Then 8 minus 13 is minus 5. Alright. Then 13 minus 19 is coming out to be negative value minus 6. So minus 6 is maximum negative. So with reference to that, you form the quantity adjustment loop. All this I have to do so often because I started with northwest corner rule, and there will be lot of adjustment in quantities, because in my initial allocation northwest corner rule method, I didn't think about cost, and now those things are troubling me, and that's why it is taking me a lot of time. Had I started my initial allocation with list cost method, or better by Vogel's approximation method, might be the process would have finished in one or two more iterations, but here I am taking little more time. So with reference to this, you can either, with reference to this cell, you can either go up, but there is no point going up, because after that your journey will stop. If you go down, if you go down, then loop starts becoming visible to you. Here it is. So here you will be having plus, minus, plus, minus. Okay. So this loop's quantity will get modified, and you will get new distribution, modified distribution, right? We will continue the things ahead of fourth iteration in the next class. Thank you. Thank you very much.